Similar right triangles. All right, so we've done other videos close to this one. It's not quite the same, but they all work out pretty much the same way. So we know they're similar triangles, and we know they're right triangles. It's in the title. So when we do this, there's a couple of ways to match them up. So the first way that I usually use is when I'm building my proportion, the angles that are across from the 90s are always similar. Sorry, the sides across from the 90-degree angles are always similar. And then also, we usually have a vertical angle here or something along those lines. We'll see. Every once in a while, they change it up so it's not the same style triangle. And then I can go the angles that are across, or the sides that are across from the angles here. So the 5 and the 3, those are also similar. So if I think of it that way, and I'm saying that this is the left triangle and this is the right triangle. So for the left triangle, I have 5 across from my vertical angle, and in my right triangle, I have 3. And that's going to equal, sorry, jumping around here too much on my colors. Brighter blue. All right. And that's going to equal, we're going to go back to left triangle. I put left triangle on the top, so I have to start back up my left triangle for the next ratio. So I'm going to go across from the 90 and I get 7.5. And then I'm going to go to the right triangle across from the 90, I have x. So now that I'm here, what I can do is just start cross multiplying. So I cross multiply, I get 5 times x equals 3 times 7.5. So I have 5x equals, and then they actually let you use the calculator on this one if you want to. So this one would give you 22.5, I believe. Let's test it real quick. 7.5 times 3. If I was actually clicked in the calculator, times 3. Okay, so yeah, 22.5. So now we have our 22.5. I'm just going to move this over here. And to solve it, we just simply go, well, I want to get x by itself, so I'm going to divide by 5. So 5 divided by 5 is 1. And I get x. And then I come back to my calculator here. I already have 22.5 in, so I just hit divided by 5. And we get 4.5. So x has to be 4.5 in order for this to work as a similar triangle. And that's exactly what they did down here. They just set it up pretty much the same way I did. So we just have to make sure that we're paying attention to corresponding sides when we set up our proportion. So let's go over here. All right, so this one is set up in the same way as the last one. So we're going to look at the 90s. So that's the first thing. We can go across from the 90, across from the 90. And we can still think of this as the left triangle, and this is the right triangle. So I'm just kind of dividing them up. So when I write my proportion, I'm going to kind of start it out like this. So I have across from the 90 on the left side, I have 7. And then across from the 90 on the right side, or the right triangle, I have my x. Now, I'm going to go over here. And on the last one, I used this vertical angle. Well, if I go straight across here, there's nothing there. If I go straight down, there's nothing there. So what I want to do is between the vertical angle, so these are the vertical angles, between the vertical angle and the 90, that's what I want to look at. So in the left triangle, and between the vertical angle and the 90, I have 3.5. And then I'm going to go to the right triangle, and I want to go between vertical and 90, and I get 2.5. All right, so now that we have this, we can cross multiply. So I'm going to go 7 times 2.5 equals x times 3.5. So let's see, we get 17.5, I believe. So 7 times 2.5, 17.5. All right. And this one just equals 3.5x. I put it this way because it's proper to put the coefficient in front of the variable. That's the only reason I wrote it that way. All right, the final task here is to get x by itself. So we divide by 3.5 on both sides because we're trying to undo what's being done. This is being multiplied, which is what we showed up here. So to undo multiplication, I divide. So 3.5 divided by 3.5, any number divided by itself is 1. And then 17.5 divided by 3.5, so divided by 3.5 gives me 5. All right, so x has to be 5 in this one. Go ahead and check, and we're good. All right, next one. Okay, so come on, pencil here. All right, so we have our left triangle and our right triangle. I'm going to set up my proportion here. So we're going to go across from the 90. That's usually the easiest one to do. So if my left triangle across from the 90, I have 6. In my right triangle across from the 90, I have 7. And now I can go look at the vertical angles. So these are my vertical angles. Vertical angle just means that I go across the vertex. That's all that means. And vertical angles are always congruent. So this is definitely a geometry term, but it's one of those things that makes it a little easier if you know that these angles across from each other like this. Whenever if two lines crossing, you can cross the vertex and those two angles have to be congruent. They have to equal each other. So I'm going to go across from the vertical angle on the left triangle and I get x, and then across from the vertical angle on the right triangle and I get 3.5. So now we're going to cross multiply here. We get 6 times 3.5 equals 7 times x. So, whoops. Did not mean to take a screenshot of that. That's one of those little silly parts of the app here. So I'm going to go 6 times 3.5 equals 21. So I get 21 equals 7x. And then to undo the multiplication, I'm going to divide. 7 divided by 7 becomes 1, any number divided by itself. And then 21 divided by 7 is 3. So I'm going to go ahead and close the calculator here so I can type my answer in and check. And we're good to go. All right, next one. So let's go ahead and go. So with this one, what I'm going to do, make the pencil a little smaller. So I'm going to go like this and show you. So there's 2 triangles stacked in here, and this is what I meant by different orientation, because sometimes they do this where they give it to you in a completely different way than they did before. So we have 2 triangles here. They're just different than we're used to looking at them. So we have the top triangle, which I outlined in black, and then the bottom triangle, which I outlined in green. So there's 2 triangles here. So we're going to go, I'll talk about, we can say small triangle and large triangle if you want. So we still have to set up our proportion here. Make this a little, oh, no, that's too big. Yeah, that works. Okay. All right, so for the small triangle, if I go across from the 90, I get 5. From the large triangle, if I go across from the 90, remember it's not just the 2.5, it's the 2.5 plus the 5. So I get 7.5. And then, let's go with red here. And then if I look at the base here, which I covered up with my line here, but this was x and this was 4.5. So if I look at the bottom here, I get x for my small triangle, and then if I look at the bottom here for the bigger triangle, I get 4.5. So it's all just about matching it up. 5 times 4.5, because we need to start cross multiplying, and then 7.5 times x. So let's go over here. We get 5 times 4.5 equals, so we get 22.5 equals 7.5x. Now remember, we want to undo the multiplication, so we divide. Any number divided by itself cancels. We bring the x down. And we divide one more time, so divided by 7.5, and we get 3. So our answer is 3. Check. And we're good. All right, we finished another one.